So if I unmute. Hello.
Hello.
Hi, everybody. Welcome to this week's Learning Space. I am your host, Nicole Gugliucci. I'm a postdoc with the CosmoQuest project. My co-host, Georgia, is doing a 2-week-long teacher professional development workshop, so she won't be joining us this week, unfortunately. So yay, Georgia, have fun. I am joined by Robert Sparks today. Hello.
Hello. How you doing, Nicole?
Good, how are you?
Good.
And we are going to talk a bit about Galileoscope and optics activities you could do with the Galileoscope. And I have trusty Galileoscope, not mine, one of the Resource Center ones. Mine is with a pile of telescopes at home. For all of you guys watching, I see a bunch of hellos in the Q&A. So hi, Douglas. Michael, you win first comment. Hi, Nancy, and good evening over in Germany to Guido. If you're watching this anywhere on Google Plus or YouTube or somewhere where it's embedded, you can click to where it says join the conversation, and that'll take you to the Q&A app, and so we'll be watching the comments there. Hello, Brandon, as well, so yay, thanks for coming, everybody. So yeah, feel free to send in any comments or questions throughout the show, and we will try and get to them through the Q&A app. So, Robert, how are you?
Good.
How is life in Arizona?
Hot and clear. Not a cloud in the sky for the last week, which has been fun.
Wow.
But the monsoons will start hopefully soon to cool us down a little bit.
Right. And the telescopes pretty much do a lot of maintenance during monsoon season, right?
That is correct.
Monsoon season, for those of you who are actually in Asia and get...
Yeah, it's not quite the same. Technically, it's not a monsoon in terms of the same weather patterns, but it's commonly called the monsoon here. Yeah, July 15th, I believe, is the date they shut down for maintenance till about September 1st.
Oh, wow.
So still a couple weeks for that, but usually the monsoons, the rains will start a week or so before shutdown, so it gets dicey toward the end there.
Yeah, it just rains constantly, which is nice. I mean, you need it.
Oh, definitely, yeah.
Cool. So I wanted to talk some about the Galileoscope Optics Activity Guide, and I can put a link to that in the, I think, I mean, I've probably have it saved somewhere in my browser, but I just Googled Galileoscope Optics Guide, and it comes up from the National Optical Astronomy Observatory, and I will share a link in the comments as well on the event pages. Yes, I know there are 2 event pages. It's very confusing. Welcome to my life. There we go. So can you tell me a little bit about the development of this optics guide?
Yeah, well, to start the optics guide, we should actually take a step back before the Galileoscope even existed, because it was based on previous work, obviously. When I first came to NOAO in 2005, the big grant we were working on at the time was hands-on optics, and I was hired specifically to work a lot on that grant. And that was a 4-year grant from the National Science Foundation to develop optics education materials for middle school, basically. We worked with the MESA programs, and that stands for Math, Engineering, and Science Achievement, in several states, which included Arizona. I think that's 8 states: Arizona, California, Oregon, Washington, New Mexico, Utah, and Maryland. I don't know how Maryland got in there. They're sort of the oddball geographically, but Maryland was one of the 8 states, and so we developed that, and we'd work with the MESA programs and do teacher workshops each year in those states on these modules we developed. And of course, one of them was called Magnificent Magnifications, which was our 3rd module, which dealt with lenses and telescope optics. And we used those old Project Star telescopes. I don't know if you remember those things or not.
I don't think so.
You're a young one. You might not remember Project Star telescopes. They're these cardboard telescopes that had a red cap on the end. They'd have like a plastic objective, then a little single plastic eyepiece. They gave I think they gave 20 magnification or so for a 50 millimeter telescope, and there was so much chromatic aberration that a field stop on it to try and reduce chromatic aberration. They were okay for educational use, but a lot of frustrating things about them for night use, obviously.
Right.
You couldn't mount them on a tripod. The chromatic aberration was ridiculous. The field of view was so small it'd be hard to find the moon. I can't remember what the field of view was, but I'm pretty sure it was significantly less than half a degree, so you wouldn't have been able to fit the full moon in there at one time.
Yeah.
They were developed back, I want to say did in the 1980s and had been around. You can still buy them online. So if you search Project Star telescopes, you can see them. They're these little red. The folks are just they're two cardboard tubes, one slightly larger, one slightly smaller. You slide in and out.
We might have a set of those in the resource center.
Yeah, they were very popular for a long time. So like I said, they're still available. Project Star got was it the learning technologies got bought out by a company in Florida called Science First. I think Science First still sells them. But of course, when the International Year of Astronomy came around, 2009, that's when the Galileoscope started being developed by NOAO, Photonics Engineering, the AAS, Rick Feinberg, Doug Arian, and Steve Pompey, and a bunch of other people working on the Galileoscope. And that's when we started taking the stuff we'd worked on for the hands-on optics program and adapting some of it to work with the Galileoscope. And a lot of the activities did transfer right over. So, but there, of course, were definitely some. We don't no longer use the Project Star telescopes. There were definitely some things we want to modify for that.
So yeah,
the Galileoscope is definitely a big improvement of the Project Star telescope.
This is actually a useful instrument for nighttime observing.
Yeah. I've actually gotten pictures of the rings of Saturn through that thing with it, and some great moon pictures as well. So I need to get out and do some more photography with it.
With what kind of camera?
I was using a really Kodak instant Kodak digital camera. Just put it up to the eyepiece and turn off the flash and click basically.
Oh.
Now I did cheat a little bit because I put the Galileoscope on a tripod and the camera on a second tripod to hold it steady at the eyepiece.
That makes sense, yeah.
But once you do that, it's actually not that difficult. And there was another, I had a little web-based camera for my telescope. I think I got it like in 2002 or 2003. I think it's called an Astrocam. It was actually a gift for helping someone out. It's just basically someone took the guts of a web camera this company did many years ago and put it inside a 1 1/4 inch eyepiece barrel. So you just slide it right into the end of any telescope. Basically, it takes a 1 1/4 inch eyepiece and photograph through that. So that's pretty neat little device that they came up with, which unfortunately the software is no longer available for Mac, so I can't use that. So I'm able to get to work with Mac recently.
Sad. So we've done a couple of episodes about the Galileoscope specifically. You can get it at galileoscope.org, I think is the proper tag at the end. You can get a case of 6.
6 for 150 is still the going rate. Yep.
150. Okay.
Plus shipping.
We have several. So we tend to buy them in bulk here because we do them for student camps and teacher workshops as well. So that's really nice to buy them in bulk. But I have one that I actually bought in 2009 in the Year of Astronomy that I still have at home in my pile of telescopes.
I just buy for myself personally. But every year or so, I buy a case for myself, and that way I have them at my house. And whenever niece or nephew has a birthday or something, or some neighbor's kid has a birthday, or someone needs a gift for a raffle, it's just like, here, have a Galileoscope. So
that's awesome. That's actually a really good idea.
You just have to keep track of who you give them to, so don't give them twice, But
yeah. Well, I've got some nieces and nephews that haven't gotten telescopes yet. I think I can start doing that. Awesome. Well, what I love about this, so we just did a backyard astronomer camp here with some students. So I'm at SIU in Edwardsville. We went east a bit to town of Mascoutah and did a workshop with students. I talked about some of the activities on this show because my guests unfortunately canceled at the last minute because internet is horrible sometimes. I talked a little bit about some of the activities that we did. So I am actually, while we're talking about this, I'm going to take this Galileoscope back apart, just like I did in the workshop, so I can show the kids how it comes together. And me having an instrumentation background, I love that you get to build this telescope and kind of see how everything lines up and see how everything works. And I think that's kind of the progression of activities in the optics guide as well.
Mm-hmm. Yeah. So, do you want to build the telescope or show them that first, and then we talk about the guide, or do you want to?
Well, why don't you maybe talk a little bit? I'm going to start pulling it apart.
Okay. Well, the guide we sort of go through. We start with we take an acrylic block. Let's see if I have the block here. Here we go. Where'd my laser go? Here we go. We just do start with the basic. There's a variety of ways to show how light bends when it goes through from air to other substances, and we have in the kit. Let me back up a second here. This is actually one of the items we used from the hands-on optics kit, and for the hands-on optics kit, we tried to find low-cost items we could use to make for the teachers. And these acrylic blocks, we get them from a company online for about $3 a piece. You know, they cut them to cut the custom shape for us and everything. So they're very, very cheap and inexpensive. And you can do this experiment in a lot of ways, but for, using fish tanks and stuff. But this is much more portable and cheaper and easier to do. And of course, a laser, and we'll take the laser and oops, where's there we go.
Yay.
Get it in the webcam field of view. We'll just sort of show them. I don't think you'll be able to see it on the camera, but sort of show them what happens when light goes through the block this way, and sort of tilt it so you can see how light changes path when it goes from one surface to one substance to another. When it goes from air to plastic or plastic to air. And we do a lot of talking about how light changes speed and it slows down and bends. Depending on the age level, of course, it depends on whether you're going to get into whether it bends toward the normal or not. But most students at least get the idea that things slow down when they go to plastic, even fairly young.
Yeah.
So it makes sense. Denser material, light slows down. Okay, it's not really physical density, but they call it optical density, which is not necessarily 100% related, but kind of is.
Right.
Kind of, but not sort of. Kind of, sort of, but not really, right?
Kind of, sort of, maybe. Kind of, sort of, a little.
So once we talk for a while about how light goes when it how light behaves when it goes from air to plastic, and this is just a flat surface. We'll take out a nice big lens here. We got these nice big lenses, and if you ever need cheap educational optics, there's a company on the web called Surplus Shed, surplusshed.com.
Okay.
And they have a variety of educational. They have an educational optics section which is all very inexpensive material. This is the big lens. You have the small one.
I have the little big
one. Yeah. But this is a bigger lens. I think it's a 100mm lens. It's a 20cm focal length. They sell it for about $3, so it's fairly inexpensive. And we'll take that, and we'll take 3 lasers. I love the way these are the lasers we used originally for hands-on optics, and I love them because they're actually laser levels. Let's see if I have one that's actually right now they're sort of rubber banded together. There's 3 of them here.
Yeah.
But they're very nice because they have a switch that, let's see, get up to the camera here. They have a switch so it'll stay on without you touching it. They have little legs so you can set them on the ground without, let's see, the little legs. Oh, there's the legs. Things are reversed on the camera. It's confusing me.
Yes, yes.
Legs so you can set it down without falling over, and they're just great. And plus, they're actually bigger than like laser pointers, so they're less likely for students to walk out with the room with them.
That's good. Where did you get those?
Unfortunately, they're not made anymore. They came from Harbor Freight.
Oh, okay.
Yeah, but they have stores all over the country. But we got them from Harbor Freight, and they're fairly cheap. They're like $6-7 a piece. So they're fairly inexpensive, but really nice in a lot of ways for what we were using them for. Nice. So we sort of take the 3 lasers and then shine them through the big lens and point them at a screen. Mm-hmm. And for the screens, we use these little vellum guys. We just have a little piece of vellum on here. And the nice thing about vellum is if you shine a laser on it, you can see it from both sides. Let's see if I can get it up here so you can see the laser spot. But also if you're on this side, so you can sort of do theater in the round. So no matter which side a student's standing on, they can see what's going on.
Right. So
these semi-transparent material, translucent material, I guess you'd call it.
Would tissue paper work for that as well?
Tissue paper works, yeah. Okay. But then, again, this is the frame here. This holds it nice and steady though, and you actually take your styrofoam cup and cut a little slit in it, and it'll hold it up very nicely for you. So it'll hold it nicely, just like we do for the lenses, which we'll get to in a minute here.
Yeah, yeah.
But this is very nice because it's very nice, and it's cheap. The vellum's cheap. The frame we get custom cut to size. They're about 40 cents a piece, so they're not expensive. And I have undergraduate students who glue them together for me, so I don't have to worry about that. So always nice to have expendable labor, right?
Sorry, undergrads. We've been there. It's okay.
Then we just sort of take this and we sort of look at what happens when light passes through here. Do you have 3 laser beams, and we say, well, okay, what's laser beam A, B, C? Which laser produces which spot? And hopefully sometimes they'll get to the point where we can see the light beams crossing. And if you want to, you can actually take the little water or chalk dust or something to actually watch the beams of the laser cross. But we always show them this before we let them see the beams, although always seeing the beams is a lot of fun.
Fog machine.
Fog machines work well too. Or dry ice, given it's off its steam, that always works well too.
We did have a situation where we had to clear the room at one point because we went a little overboard during a laser bouncing challenge, but fun.
I do a lot of theater, and many years ago I did Damn Yankees, and we actually had to evacuate the theater because our fog machine set off the light smoke alarm. So. Oh yeah, the fire department came and everything because the alarm's wired straight to the fire department. So yeah.
Whoops.
Yeah, whoops, easy on that fog machine, so I know how that goes. Had to evacuate 300 people because of it, too. So.
Oh, so we only had a handful of students. We were just like, okay, everybody go play outside for like 20 minutes. Let's play asteroid accretion tag.
Then after that, we actually go on and play with lenses for a while. We
Mm-hmm.
play with lenses a lot. We have these, again, surplus shed lenses. These are nice little lenses. They cost about $1 a piece.
Nice.
So we have two. We actually give them two different lenses. One which is, we call it the thin lens because looking at the edge, it's much thinner.
Mm-hmm.
And of course, the other one, which I'm just getting out here, is called the thick lens. Because if you look at it from the edge, you can see it. Hopefully, I think that shows up there in the camera. They're different shapes.
Yes. Yeah.
One's much thicker than the other. And we start asking students to find the focal length. And typically for younger students, we just use the very distant object. Because if you use a distant object, and distant means many multiples of the focal length away, the focal length is approximately equal to where the image forms. So you don't have to do any complicated math. Of course, for older students, you can use the thin lens formula if you really want to, and use a close object and make them do the thin lens formula. But young students, you can actually get the focal length pretty close just by looking at a very distant object. And for very distant objects, if you don't have a window available, we use neon lights. So you have a whole bunch of these big neon lights. I'm not going to take it out here, but they buy these online for about $15-20, and they're big. Basically, this one's what's this one? I'm not going to turn on. There's a big butterfly light.
I remember using that one at ASP.
Yeah, we broke one there, didn't we?
Yes, we did. Not it. I was in the back of the room.
You're not. It wasn't you.
I'm claiming not it.
So we can project the images on the screen and find which lens has a bigger, longer focal length, which lens has a shorter focal length. They're made of the same material, so it's just dependent strictly on the shape of the lens for these guys. Which one makes a bigger, is the image right side up or upside down? You can definitely see the upside down image. Which lens gives a brighter image? One lens gives a brighter image. Which lens produces a larger image, smaller image? There's a lot of experiments you can do with these lenses here to start looking at how these lenses behave. Then after that, we sort of look at the eyepiece part of the telescope. That sort of simulates the objective. You form the image with a single lens. So you sort of move on. We don't tell the students that the objective of a telescope, and we don't tell them the next step is looking at the eyepiece of a telescope. The next step, we sort of take these lenses and turn them around and start putting them closer than a focal length, look at very small print, pennies, that sort of thing, and use them as magnifying glasses and let students explore the magnifying properties of these lenses. Where's the flip point? If you're very close to an object, it's magnified, but if you get farther away, you look through the lens, the image flips over and is upside down. So sort of hopefully they'll get that the flip point happens roughly near the focal point and ask them which one's a better magnifying glass. And then, so we haven't said anything about telescopes yet, but then we start saying, okay, now let's put these combine two lenses, to put one by your eye, one out here, and see if you can make a telescope. And of course, the goal is to make an image that is magnified. Put them backwards, the image is smaller. But we don't tell them which lens is objective, which one's eyepiece yet at this point.
Figure that out.
And we, of course, try to get the idea across that, we also have measured the distance between the two lenses when they get a good image. And so say, is there a relationship between the distance between those lenses and their focal lengths? Which for a telescope, of course, you simply add them. So that's fairly simple, even for relatively low-level math students, to add two numbers together. That was a nice little thing there. And then, of course, we can do one more step. We try and really figure out how do you get across the idea that the objective forms an image and the eyepiece is your magnifying glass. And the way we do that is we actually take go back to our vellum screen. We'll have them set up the lenses with the styrofoam cups, which you had a minute ago. I think I have some.
They're actually from the workshop or pre-cut by the students.
Yep, I have cups in the back of my room here. It's very easy. If you want to do a nice job cutting, you can, but if not, you just sort of push the lens in there and make a little slit.
I think we just gave them to let them go to town.
Yeah. They can actually hold the lenses, put the screen in between them, and they can see that the first lens forms an image on the screen. Right. The second lens goes on the other side of the screen, again, one focal length away, in that they look through it and they can see it magnified. And of course, when they remove the screen, they see pretty much the same thing. So it's just a way of letting them actually see the physical image formation without all you need is something to reflect off, and you get that image formation to actually see the image is really there. Move the screen, the image is still there. They just can't see it because there's nothing for it to reflect off of. So we try and get through that, and we of course will go through, depending on the age, we'll go through the magnification formula, focal length of objective divided by focal length of the eyepiece. And as a photographer, one of my favorite little things I always like doing at the end is going back to this first lens. We have the large lens, has a big diameter and the smaller diameter lens, they have the same focal length.
Right.
It's always interesting to ask students, what if I take both these lenses and project the same image, how will they be the same or different? What properties will be the same, what will be different between these two lenses? And then, of course, if you want to get to, I'm into photography, so with older students, especially like high school students, I will get into the focal ratios of lenses.
Mm-hmm.
Because what lens is fast, what the difference between a fast lens and a slow lens.
Right.
So I'm really into photography, so I like doing that with the older students in particular. And photography students, you always get one or two students who are really into photography say, oh, so that's what those numbers mean, which is always a lot of fun.
Cool.
Then we go on to building the Galileoscope,
right.
which of course you have right there.
Yes, I have it in pieces. So we didn't. So we used some of the. So we don't have the same lens kit, which it's really nice lens kit. Oh, but we kind of went through our optic stuff and pulled out lenses to use for that. So it's slightly different focal lengths, but I was able to figure it out from the average of the students. And instead of those neon lights, because we didn't have one of those on hand, I don't know why we have this, but there's a big cork board. I wish I'd taken a picture of it with red Christmas lights that make a big arrow. It was just looped back and forth, making a big arrow. So this big lit up arrow, actually kind of pink arrow. So with just Christmas lights, you can kind of make a shape. And
I've done that before too. One time I told you about the hands-on optics project. We had to do workshops all over the country, and one of the workshops, our neon light got broken in shipment.
Oh, no.
So of course, what we do, we run to the store and grab a string of those LED lights, that, like you mentioned, Christmas type lights, and just improvise with them. So we've used those too.
Nice. Yeah, I mean, I think it's for an optics demo, because when else do you have a big lit up arrow?
Yeah.
Yeah. For science, at least. So yeah, I have the Galileoscope in pieces, since this one came all together to. I'm gonna make you guys slightly motion sick, so hang on there. So I've got it mostly in pieces now. I haven't completely taken the eyepiece apart, because the last thing I need is them rolling off my desk and having to chase tiny lenses. But I've taken the eyepiece. This is always one of the hardest things to do with students, because you've got to follow the instructions on which is the curved side, which is the flat side. Try not to get your fingerprints on it as you're putting it together.
What you just showed are actually two lenses, not one. So there's actually 4 lenses there total, not 2.
Yeah, and that's I'm afraid to pull them all out and have them roll apart. Yeah, so there's 2 here, and then 2 here, and then this tiny little ring, which somehow everybody managed to miss when we were unpacking. We had to go through the boxes that had already made their way to the garbage.
Actually, recycling. Just so you know about that, that's actually just a field stop.
Right, right.
The Galileoscope has a field of view of 1.5 degrees specification-wise.
Right.
But if you remove the field stop, the field of view is slightly larger, closer to 2 degrees.
Right.
And so it's actually an interesting experiment to remove that field stop and see how it changes the image. Okay. And if you do it, you'll notice that way at the edge of the field of view out there, stars are distinctly not round anymore. So that sort of just cuts off that very outer part of the field of view where the image gets really ratty.
Here we go. I can show
but
you
the scope works just fine without it.
The 2 lenses that pull apart here.
Yeah.
So I think I was teaching. Okay, so we had mostly middle school age kids. So there's the convex, and that's like the bubble, and the concave is like the spoon, and having them figure that out as we went along. I want to pull down some comments we're getting. Guido was talking about photography through the eyepiece of a telescope. The bigger your lens, the more difficult it gets. I was able to do that with my small compact cameras and my little Newtonian, but it doesn't seem to work with my bigger bridge cameras. So I don't know if you have any thoughts on that. Throw my camera phone, my brain. I throw my phone camera up against the eyepiece. He says he has trouble photographing through the eyepiece of a telescope with a bigger when there's a bigger lens. The smaller compact cameras are easier to use. Yeah,
small compact cameras, the one I got my pictures of Saturn and stuff with, and they're very good. For cell phones, Ryan makes this little adapter here, which goes over your eyepiece, then your cell phone goes in this guy.
Oh yeah, I just saw that. I was looking at tripods, and it advertised that.
I love these guys. I think they're about $60 a piece or so, but they adjust. You can get them specifically for iPhones, but I got to the universal one since I have a Galaxy, and it works with the Galaxy S4. But it gets a little tight, so if you got like a Galaxy Note, this probably wouldn't quite do the trick. But up to Galaxy S4, S5, it works okay.
Yeah, phone's bigger than my hand. I
Yeah.
draw the limit. I
And,
like my big phone, but they're getting a bit large.
and I have the SteadyPix also, which is a similar device, except it works for digital cameras. It
Okay.
has this goes let's see, this guy goes over the 1 1/4 inch eyepiece holder, and your camera mounts on this little quarter 20 nut here.
Okay.
And so they're getting Ryan sells things. A lot of companies sells these things. I think these are a little cheaper. I think this one's about $30.
Okay.
So I think this one wasn't quite as much. It also comes with two eyepiece things. So if you have 2 inch eyepieces, it comes with a second guy you can replace and use a 2 inch eyepiece as well.
Nice.
Unfortunately, I have tried this one with the Galileoscope, and the Galileoscope, because it's that thick plastic, this does not really fit over the Galileoscope tube that well. So I have tried this one, but it really doesn't fit the Galileoscope well.
Gotcha. We have, let's see. Tom Nathy, I'm not going to display this comment because I think it'll make it go away for everybody, but if you're using the Q&A app, there is a link to Harbor Freight where he found a 2-in-1 magnetic torpedo laser level.
Ooh.
Screen I didn't actually read the title before showing it, so apparently, does this look similar to what you're using?
Yep, that's very similar.
Okay.
A little more expensive, but similar. Yes, very similar.
Gotcha. Cool. So if you're looking to do that laser demo bit.
I have. I think that similar to this, isn't it?
Oh, nice. Yeah, it's got the 3 axes.
Yep. So that there's a good chance I have. If there's a good chance I've tried to at least looked at it or seen it in my life, because we've had to find new sources for lasers over the years and test new models. And actually, those orange ones I showed off earlier, I'll just mention one of the other main reasons we liked that one is it passed the drop test. Literally, when we were making the hands-on optics kits originally, we bought probably about 12 to 15 different types of lasers and just started dropping them on cement floors and seeing which ones survived the best.
Oh my god!
Because we were thinking, kids are going to drop these things, so those plastic orange ones did a very good job of surviving. They had a high survivability rate.
How many students do you usually have in a workshop?
It depends on 15 to 30, somewhere in there. No class size, depending on the size of the class.
Okay. So do you want me to put this Galileoscope back together now?
Sure. But the biggest Galileoscope builds we've done, the biggest one we've done was a program with Raytheon here in Tucson called Math Moves You a few years ago.
Okay.
And Raytheon in Tucson rented out the U of A student union ballrooms and invited students from all over Tucson. And one day we were shooting for 500. We just missed it, though. We had about 480 students build at one time, Galileoscopes.
How many helpers did you have?
A lot. Well, this is actually part of Raytheon. They have their leadership development program where they bring young engineers from around Tucson, from around the country to Tucson in the spring for a week-long training session and workshop, and this is part of that. So you had about 70 to 75 Raytheon engineers who sometimes needed more help building the scopes than the 5th graders, but that's another story. No, they were great. They were wonderful. But we had the students like tables of 7 students with 1 engineer there. So had 1 person helping each table of 7 students. And before the actual day of the build, we had a separate workshop with all the engineers where we taught all the engineers to build the scope. And then a few days later, we had the big event at the student union where all the students came and built the scope. So our record is just under 500 at once.
Oh my gosh.
That's
That's amazing.
And of course, we have the Tucson Amateur Astronomy Association helped us out, and they had another dozen or so volunteers there to. And then we have our undergrad students from the National Observatory here as well. So we had probably close to probably in the 90s in terms of helpers at that event.
Okay, that's good.
Total.
5 to 1 ratio.
Yeah, which isn't bad, but it's a huge event.
Yes. We have some questions about the Galileoscope in terms of how closely it relates to Galileo's original telescope. Michael Jobin asks, was was his stopped down as well?
That's a great question. The Galileoscope that we developed is not stopped down. That Project STAR, that cardboard telescope is, just to clarify that point. But Galileo's, he had a variety of telescopes, and the goal was not to recreate Galileo's telescope with this project. The goal, because his telescope had a very small field of view, very poor optics, a lot of chromatic aberration, and was just overall difficult to use. So we didn't want to create a telescope difficult to use.
Hmm.
Instead, the goal was to create something about the same size, about the same diameter, and about the same magnification as Galileo's telescope, but with a more modern optical and mechanical design.
Hmm.
So it was not to recreate his telescope exactly. And from what I've read about Galileoscopes, he made a variety of scopes. He didn't just make one, of course.
Right.
His first ones had magnification, I think, around 6, I want to say.
Okay.
Fairly low magnification. But by then he got up around 30. Ours is 25, so it's at the upper end of that range, but in the range. And his biggest telescopes got up to around 2 inches, and we're at 50 millimeters, which is right at 2 inches. So,
Okay.
so we're in that range of what he did. But it's not, and of course we have a very modern Plössl eyepiece design, which uses 4 lenses, two types of plastic, which Galileo didn't have, and the
Did they
objective
have
lens
plastic
is
at
a
all?
what?
Did they have plastic at all?
No plastic back then, believe it or not. And the objective lens is even a doublet, and you might have it there. You can hold it. I don't know if it'll show up on the screen, but it's actually 2 lenses. Yep, I can see the line there.
Yep.
I can see the line on the lens. 2 lenses glued together, so therefore it's like what made of different types of glass with different curvatures to reduce chromatic aberration.
Right.
Galileo's telescope couldn't even see the full moon at one time. It had less than half-degree field of view, whereas this has a 1.5-degree field of view. So there's a lot of better eye relief, which is nice for people wearing glasses to use it. So this is a much more modern telescope than he did, and intentionally designed that way. Now, if
Yeah.
you want to, if you really think that's making life too easy for you, you might have it there, Nicole. It
I
comes with a
don't have it
second
with
eyepiece.
me, but I know what you're talking about.
It
Yeah,
comes
the same.
comes with a second eyepiece, which is a Galilean style eyepiece.
Mm-hmm.
The main eyepiece, the Plössl, is a converging lens style eyepiece, but Galileo used a diverging lens. So we
Okay.
include a second eyepiece, which is a diverging lens style eyepiece, and that has a very small field of view, very poor eye relief. You can't even get the full moon in there at one time. It's less than half-degree field of view. So if you really want to experience what Galileo did, you can get a much better simulation of it by using that second eyepiece. And of course, that second eyepiece can be taken apart, then used to create a Barlow lens, which will double the magnification to 50. So we didn't include that lens just to frustrate you and show you what a lousy telescope Galileo had. Well, that is an added bonus.
It's a great teaching opportunity.
Yeah.
Yeah, that was Michael Jobin's other question, was whether Galileo had a compound lens like this. So
No,
no, this one with 4 lenses here is not like the one Galileo used. This is the modern, nicer one. I don't have the second eyepiece for this particular kit with me, but I had the students make it, and I had the students try it and see the difference, at least during the day.
Even our diverging lens is better than Galileo's, because Galileo used a singlet diverging lens and ours is a doublet. So it's two different types of plastic. So even though it has the small field of view, it does have better color correction than he did.
So chromatic aberration means that the different colors refract at different angles, so they don't quite come to the same focal point. How bad was Galileo's chromatic aberration?
That's a great question. I'd love to look through a scope and really find out.
Yeah, I saw it.
Even some of the inexpensive department store telescopes I've used, when I was a kid, had pretty bad chromatic aberration. So I imagine his was even worse than that, because you look at the moon, and there's this strong bright purple ring around the moon, and it's pretty obvious something weird is going on there. So I imagine his is even worse than that.
Yeah, here's the lenses pulled apart again. There's the two. So this one is...
The lenses for the diverging the lenses for the Galilean eyepiece are even smaller than that one.
Yes, they are.
They're nice and small to work with.
Bitty. Oops. Flat side goes out. Yes, I still remember how this goes, because I had to help 8 kids put it together. Yeah, when I was using the telescopes at University of Virginia, we have a couple of at the McCormick Observatory, we have a couple of Clark refractors. One was big 26-inch, one was a really small 6-inch.
Those are fun.
Small 6-inch had this purple ring around everything, because it had pretty bad. I mean, it was good. It was good. It was still better than what Galileo had, I'm sure, because it's a 125-year-old telescope, not 400-year-old telescope. But there's a purple haze around everything.
I've never gotten to look through I've looked through the Yerkes 40-inch, which is a Clark telescope, and the Flagstaff 24-inch, which is another Clark.
Okay.
But never at the moon. So I've never got seen the moon through either of those two.
Oh, it's good. Through the 26-inch. I've never looked through the 40-inch at Yerkes, unfortunately. It's been closed or otherwise occupied the 2 times I've been there. So.
Yeah, that's definitely a treat.
Sad. Okay, so do we want to put this thing back together?
Like, stop bragging, people.
Yeah, right. They're like, we don't care. Oh, here we go. Tom Nathan says, do a Google image search for smartphone telescope holder DIY for do-it-yourself ideas to make your own smartphone holder for telescope photography. I might do that.
And actually, that actually brings up a fun point because on the Cloudy Nights forum, back when it's run by Astronomics, it's one of their astronomy forums. When the Galileoscope came out, there was actually a lengthy, very fun thread called "Pimp My Galileoscope," and they actually had all the modifications people made to Galileoscopes. And I think one of my favorites was the focusing mechanism someone made. The regular Galileoscope just slide it in and out, right?
Yeah.
But they actually used Legos of all things. They actually used Lego and made a focusing mechanism where they actually mounted part of the Lego on the scope, another part on the focusing tube, and then had a little knob with gears where you turn it, which would slide the focusing tube in and out for you. So they did a homemade Lego-based focusing mechanism for the Galileoscope.
I want.
So, yeah, so if you look at the Cloudy Nights forum, see if you can find that thread. I believe it's called "Pimp My Galileoscope" was where it was. But there's all kinds of fun things people did with Galileoscopes in there that you can look at and see all the mods they did.
To distinguish it from everybody else's. Oh. I'm trying to read another question from Lily. I've got to start a Donors Choose project, so I can start this with my Earth and Science students. Most of them have never seen a telescope up close, much less build one. Do you have to wait till night to use them, or have you tried to use them during the day?
Well, during the day, typically you can use them for terrestrial observing. The Galileoscope is not designed to be a solar telescope. Obviously, you don't look at the sun with it. There's even a little sticker that says, "Don't look at the sun." Or your eyeball will burst into flames. Show them the eyeball bursting into flames part.
Oh my God, that's right. I forgot about that.
Yeah, the eyeball burst into flames. So don't look at the sun with them.
So this is why I can't get anybody to look through a solar telescope. Like, I have a Coronado here at the department, and people are really skeptical because we tell them, don't look at the sun through a telescope. I'm like, no, but this is a safe one, and they look at me like I'm crazy.
Yeah. Well, I always tell people that don't look through a telescope at the sun unless the person who's telling you to look through it looks through it first themselves.
There you go. That's a good one.
If they look through it first themselves and they can still see that, you might have a chance. But, and also, some people do solar projection, of course, where they point the telescope at the sun and then project the image of the sun on a piece of cardboard or paper behind the telescope. But that's not recommended with the Galileoscope either, because the lenses get very hot.
Yes.
And the lenses in the Galileoscope are made of plastic. Right. And what happens to plastic when it gets hot? It melts. But and we did test this one time. I took a Galileoscope outside and pointed at the sun. Yeah. Just didn't look through it. I point sun without looking through it, and waited about 10-15 seconds. And sure enough, I start seeing smoke rising from the eyepiece. So
10 seconds?
Yeah, you will melt the eyepiece.
Oh my God!
So don't look at the sun. Don't even try solar projection because you'll melt your eyepiece.
Don't even point it in the sun's general direction.
Don't point it in the sun's general direction. So even if you don't look through it, you'll still just literally destroy part of the telescope.
I did a solar projection thing in high school with a cheapy department store one.
Yeah.
And it totally melted the glue.
Let me grab something else here just a minute.
But my Orion, I have a 3-inch Orion Newtonian that I do solar projection with, and it has not ruined the telescope yet.
Now this is a way you can use the Galileoscope to look at the sun. Directions for doing this are online. This was developed for the transit of Venus a few years ago.
Oh yeah. I mean,
basically, you have to buy another eyepiece because it doesn't have plastic lenses. But you buy a cheap eyepiece for about $10 or so. Surplus Shed has some cheap eyepieces for $10 to $15, and you sort of put that in there. Go to your auto parts store, get one of these funnels, and get a little piece of movie screen fabric for the end. Yeah. And then you can just insert this into your Galileoscope and project an image of the sun on this end without damaging your Galileoscope.
So it doesn't damage the objective.
Yeah. No, it does not damage the objective. It's the eyepiece that's the problem. Yeah, the objective is glass. The objective is not going to melt.
Right.
And it's really when you take the light that's collected by the objective and focus it down to a smaller area, that's when it gets bright and intense and dangerous. So the objective light's still all spread out, so it's fine. But this is a nice little device that they actually developed. I think on the transitofvenus.org website is what they have the directions on how to make this. And I forget what they called it, so I can't tell you what to Google. They had a special name for it, but I forget what it was.
I went to Home Depot and put one of those together myself. Instead of, I didn't have any fancy screen, I think I cut up a white T-shirt.
Yeah, you can do that too. But when they made this I made this when they were showing them off the ASP meeting a few years ago. Yeah. That's Astronomical Society of the Pacific for the Uh, keep the acronyms to a minimum, right? Undefined acronyms to a minimum. And they've made these, and they actually bought the good movie screen. They bought if you buy it in bulk, it's pretty cheap, but it might be difficult to get a hold of for just small quantities. So
yeah, as usual, I was probably putting this together the day before.
yeah.
So.
But like I said, a pinch, a white T-shirt or something will do. Anything like that will do the trick as well in a pinch.
Yeah,
But
yeah.
this was a very nice little device they came up with, which was a lot of fun to play with. So I have used it for solar projection with the Galileoscope, just for demonstration purposes.
And it's great because you can have a bunch of people looking at it at once.
Yeah,
I mean,
yeah.
same thing, you have it on a pad of paper too, but if you have it on the screen, everybody can kind of see it, and it's stable. It's pretty stable.
Mm-hmm.
There aren't really many sunspots on the sun right now. There's some really pretty prominences.
Yeah.
Reporting in from the Coronado I used this weekend, there were like no sunspots, but there were some nice prominences I could show. So yeah, no, I forgot about the eyeball bursting into flames. I should have pointed that out to the kids.
I love that. I love that graphic on there.
I was like, look at, boom. I just think that's great. We have, and Lily added, that is awesome because some kid would use it during the day. Or I think some kid would probably try and look at the sun. So that's why the sticker's very important. I was thinking you can look at the moon during the day as well.
You can look at the moon during the day. I have done that, yeah.
You can do that. It's kind of washed out, though.
Yeah, it is pretty washed out, but you can do it if it's in a pinch. It'll work.
Yeah, I said I had them, to test it out because it was cloudy. We had them like look out the window at the trees. We had them look at the exit sign, and especially the exit sign because then they could tell me, is it upside down? Is it right side up? Is it backwards?
Well, one of the other activities we'll do with the Galileoscope sometime, and it's very difficult to get across the idea of resolution to people, which is really the important part of a telescope.
Yeah.
And so one thing that we've done is we've actually gone online and got some eye chart templates for eye charts. And we'll take the eye charts, and everyone can understand eye charts mostly. 20/20 vision. This line should be able to read 20 feet away, right? Yeah. Well, with the telescope, we sort of take that and say, okay, how far away can you read this line with your Galileoscope? If you can read it at 100 feet, that means that you have 5 times better vision than with your eyes. If it's 200 feet, it's 10 times better vision. So we just sort of have students move the eye charts back and forth. You need a big field to do this because you can't see it quite a ways away, but that's another way of, without going into like radians and arc seconds and all that nonsense, to get across at least the idea of resolution to students on a basis which they probably have some experience with. Even fairly young students have seen an eye chart.
Yes, yes.
Of course, we sometimes also use the advantage of our modern computers and printer to print the eye chart upside down and backwards so that when you look at that through the telescope, it's correct.
Nice.
So they actually see the letters as they should appear rather than upside down and backwards, which does make it a little easier to read.
Well, some of the eye charts, some of the eye charts I've seen, they have the E, and then they just turn the E in all different directions. You have to tell them which direction it's pointing.
Yeah.
I was always
in that case, it doesn't matter. Yeah.
Yeah, then it doesn't really matter. For me, I can report that the big E is blurry without my contacts.
That's about what I can do too.
So sad. And yet you're an optical. I went to radio. I blame that partly on the bad eyes.
Yeah. I've done radio. I've worked at Green Bank too, so.
True. That's true. Yeah, Green Bank.
My goal is throughout my career to complete the entire EM spectrum.
See, I started at high frequency radio and just went to lower and lower frequencies. Just went the wrong way. So I'm going to put this thing back together. So there are instructions that come with your Galileoscope to help you put it back together. I've never used them personally because I think the first time I was handed a Galileoscope to put together for an outreach event, we had, the sun was setting and we had like 10 minutes and we had, 4 grad students were like, all right, we don't need instructions, we'll just do it. And we managed to get it together. But there are instructions that come in the packet. Are those the original? Because I remember there were some complaints about the original instructions. Is it still...
No, those are not the original instructions.
Those are not the original instructions. Okay, okay.
If for some reason you find a Galileoscope that has just 1 page of instructions printed front and back, throw those away. They're awful.
Or save it for...
I'm not going to go into the sordid story of those, but that was just for the first run of Galileoscopes. Those were in there, and literally part of it was because they told us you only had 1 page. But after the second run, they said, we'll give you 5 pages. So the 5-page version is much better.
Yeah, because the one we used with the students 2 weeks ago was fine. It was
yeah. Like I said, but there's only that first run, which hopefully those are all gone by now.
That's probably the one I have, but I probably didn't save the box because it's me.
Yeah.
So which way, since I took it out without looking, which lens goes towards the outside? The thick one?
The thin lens goes toward the front of the tube and the thick toward the back of the tube. So the thin lens toward the object you're looking at, and the thick one toward the eyepiece.
Ta-da!
Ta-da! Yep.
And I didn't, like I said, I didn't take the eyepiece apart, but you do have to put the 4 lenses in here
Mhm.
and the field stop, which it ended up in the other half. Yeah, be very careful when you're unpacking this because you you won't notice this piece.
Yeah,
We
sometimes that
apparently
little piece falls down. That
Hmm?
little piece will fall down in the box.
Yeah, yeah. We missed it in 8 kits. We recovered them all from the recycling, but we had to dig through the recycling. So this kind of cheating because this is probably takes the longest to get them all in there, in the eyepiece. So what activities have you done recently with the Galileoscope?
Well, we did another math moves you with Raytheon this year. They've scaled back slightly from the 500 students. This year only did about 200. So
Only
only 200 at a time.
Nice.
But our next big we've been working with the Science Foundation Arizona a lot recently on their Galileoscope program, and their goal is to bring Galileoscopes to schools around the state.
Okay.
And typically, what we'll do there, they focus on what they call rural Arizona.
Mm-hmm.
Now, in Arizona, rural means not Tucson and not Phoenix.
Okay.
That's a lot of area to cover, so to
A
speak.
lot of Arizona.
We'll typically we're going to be doing Marana this year and Flagstaff, I believe. And we'll be going up there and we'll literally do a teacher professional development workshop, an all-day professional development workshop where we go through a lot of the activities from the kit, how to build a Galileoscope, and then the teachers get a Galileoscope optics kit, which have some of the lenses and lights and lasers and all that stuff in it. It comes in a nice little bag. We call it Teaching with Telescopes. We have these Teaching with Telescope kits. They get a duffel bag with all the equipment they can take back to their classroom to do these activities. And they also get a set of Galileoscopes, roughly, depending on the size of the class, roughly 10 Galileoscopes or so,
Mm-hmm.
take back, and tripods take back to their class. They go through the optics activities. They build them with the students. Then we end up doing a district-wide star party with them. So we'll go up there, and we'll actually, before the star party, we even visit all their classrooms. So we'll have an NOAO representative, me or one of my students, or Steve Pompey. Will come and visit their classroom, make sure all the Galileoscopes are assembled correctly, get them ready for the star party, then have a big star party. And we've done this in Yuma, in Safford, and Globe, and Payson. And we did one in Flagstaff a few years ago too. And these star parties will sometimes attract 500-600 people for a star party as well. We usually focus on the 5th or 6th grade students in the district and their families. So
I love that this comes together with these. They're not really rubber bands. They're more like
O-rings. Yeah, they're little O-rings.
That's what makes it easy to take apart and put together. So here's the focuser tube.
And I found out that they last about 4 years in Tucson before they dry out.
Oh wow.
But fortunately, they're standard size O-rings, so you can get them at Ace Hardware for 10 cents a piece or so. So
Nice.
Every 4 years, you're going to have about 25 cents worth of maintenance cost on your Galileoscope.
Oh noes. So yeah, that goes in here.
Yeah,
right?
deal breaker there, huh?
Yeah, right. Maintenance. Brr. Oh, can't forget the nut because that's how you can put it on your tripod.
Standard quarter 20.
I hope I'm putting this together right. So I've got focuser tube, objective.
Yep, looks good.
Nut. Do I have now the U's? The U's.
U-vents are on the outside. Yeah, they go out on that end, so you're correct there too. Yep.
Okay. I think Pamela has one she painted bronze for a steampunk astronomer costume.
Ooh, cool.
So you really can go to town decorating these. Now, getting these O-rings around is a little futzy sometimes.
Yeah, we don't recommend dropping it too often, but I have dropped mine repeatedly and it still survives. So just because I've had it for so long.
The telescope itself survives the drop test.
And I don't even put out on those external O-rings all the time myself. I sometimes leave those off just so it's easier to take apart because I take mine apart so often.
This isn't even mine. I should put it back together.
Yeah.
This is one of the STEM Center ones. Yeah, there was a bit of I find this one must have come apart several times because this one's pretty easy to do, but the brand new ones we opened with the students were a little tough to get over. But it could also be the tiny fingers.
Yeah.
Tiny middle schooler fingers.
Yeah, sometimes for students, at least let them do that part in partners, so one person holds the scope while the other person does the O-ring.
I think I put this.
Let them help each other out a little bit.
Where's this back piece go? Oh, that was supposed to go on first, wasn't it?
And just in case you're wondering, you can actually take off the the what you haven't put on yet, the big stray light shade at the front of it. Now the
Yeah.
front one. If that's not on, it'll fit in a standard airline carry-on. So I just take
Really?
that off. Yeah. So, and
That I didn't
just
know.
in case you're curious, TSA does not stop you for carrying a Galileoscope through security. So trust me on that
Well, it
one.
doesn't set off the metal detectors, I
No,
guess.
no metal detectors, and but they don't even give you funny looks at the X-ray. You know, the X-ray machine, they don't give you funny looks.
That's funny. There we
Which
go.
sometimes when you carry something unusual shaped through there, they'll look at you just to see what it is.
Yes. Well, when we carry bags full of, we have little CosmoQuest pins,
Mm,
those, because that's all metal, and then they're like,
yeah,
what the heck? And then you can explain what CosmoQuest is, and they're like, okay, move along.
yeah.
Ta-da!
Well,
Telescope.
sometimes people see things they don't know what it is, and you know, if you have a Dobsonian telescope, and you set up in your yard, there's at least a small but non-zero chance that the your neighbors have called the cops on you for setting up mortar launchers or something.
Shoot, that would look like that.
Yeah, that happened to me once. So I
Really?
had a nice chat with the police who thought I was going to launch because I was called reported for launching mortars from my front yard or something
Oh my
by a
god.
neighbor who didn't know what it was.
People did ask me, what am I spying on? I brought a telescope to the custard stand for an event, and I'm like, what? No, we're looking at the planets.
Mhm.
So, put the eyepiece on. Um, there's also a link in the comments now to a Lego focuser for the Galileoscope from a
Oh yeah, they
blog.
found it.
So thank you, Tom. Tom's good. Tom's good with the links. So check that out. Like I said, I'm not going to post it on the video screen because that'll make it go away in the comments. So you can check that out there. Because yeah, some I think with little hands, they have trouble getting the focus right,
Mhm.
and I try and teach them to just. I mean, even though you don't have to twist it, I find it easier when I twist it.
Yeah, I
It moves a
twisted
bit,
too.
it moves a bit more smoothly. So finding the focus, but we managed to get them out there the next night, not the night we build them, but the next night, and we gave them so for the cost of the camp, they got a Galileoscope and a tripod, and we're able to get Jupiter before it's set, and I think Saturn as well. A whole lot of them, and their parents came, and they were just like, "This is so cool!" So
But I
it
will
was
say that
really
even though
great.
it's only a 2-inch telescope, from a dark site, if you have a really, really dark site, the first time I did this was Bryce Canyon National Park, so we're talking dark.
Yeah.
If you can look at Andromeda through the Galileoscope, it's a very pleasing sight because the Galileoscope has a bigger field of view than most telescopes. So you
Yeah.
actually see more of the galaxy at once, and it's actually very pleasing through there. I was actually pleasantly surprised how good Andromeda was. I mean, looked at Andromeda through 6-inch scopes and didn't see as much through the Galileoscope. Not because the Galileoscope is that much, bigger or anything. It's obviously collects less light, but your 6-inch telescope might have a field of view like yay, so you just see the central core.
Right.
Galileoscope has a field like yay, so you see some more of the disc and arm, more of the disc.
I don't think
So
I've
it's a much
actually done that. I haven't actually tried that yet.
like I said, get a dark sight. 'Cause it has to be fairly dark sight to see
Okay.
it extend out there. Otherwise, you'll just get the core. But from a dark sight, Andromeda is pretty impressive.
Cool. So Andromeda, Jupiter, Saturn. What else?
Jupiter, Saturn. Pleiades are great too. Same thing with the Pleiades. The Pleiades are big objects, so they actually see more of it through the Galileoscope than you would with a bigger telescope in a small field of view. The Beehive is a great one too, another good one.
That's up
So
now. Yeah.
The Galileoscope really excels on big objects. I think it's M7, the globular cluster off the tail of Scorpius, if I remember correctly, is another very good one through there.
You may be a bit further south than me.
Yeah, well, I'm a little farther south.
That's
Yeah,
in the horizon for me,
yeah.
or in the
But
glow of the oil refinery from our campus site. Sadly.
there's a lot of great objects through there. Orion Nebula is, of course, great through there. I'm trying to think of some other ones. I've actually even from a dark side, I've actually gotten let's see, Titan, Saturn's moon. You can always get Titan. Titan's pretty easy to get with the Galileoscope. Saturn's moon, Titan. But I've also gotten from a very dark site. I can't remember which ones were they. I want to say Dione and Tethys.
Really?
I actually verified it with an app to be sure that I was looking at that. It's like I'm seeing two things here. I wonder if those are actually moons. If they're just weird stray stars. I call up my app. Like, wow, I think I'm getting those two moons there.
I'm curious.
So,
What app do you use for Saturn? Because I have a really good Jupiter one. I don't have a Saturn
yeah.
one.
Oh, I think it's actually there's oh god, I have to look it up. It's not actually an app. There's a web page that maps them every night. You just go to the web page. I think it's the University of Washington web page that has a map of Saturn's moons. I just Google Saturn moon's position. This web page comes up and it gives me a nice map of them every time. So
Cool.
it's bookmarked in my cell phone, but I can't remember the link.
So we have a few more comments. Let's see. The scope looks a lot nicer than my 50X Tasco. It's Michael Jobin. I had a telescope back
That's
then.
good. I have a Tasco pair of binoculars which I want to replace.
Mine was little and red and had tiny little tripod feet, and I could see the moon from New York, and that was it. And Nancy said she was able to use her cell phone camera to take a handheld photograph through a periscope eyepiece this weekend. It was tricky, but managed to get something.
Interesting.
I didn't have anybody show up for the summer start party. I get lots of students during the fall and spring from the local high schools and the college, but
Mhm.
with classes out, there weren't as many people, so I was like, I'm gonna take some vines of Saturn through the 8-inch, and I just put the phone up against. Had to find, because the cover's slightly weird. I had to like
Mhm.
find the right angle to get it on, and I took some little vines of Saturn through the
Yeah.
uh, through the telescope. Michael Jobin loves his 40 millimeter Plossel. Lots of Plossel love here.
That's another thing something we should mention is it is a 1 1/4 inch eyepiece, right?
Hmm.
So if you have other eyepieces, you can slide them in there.
That's standard size, yeah.
Yeah, that's standard size. So a lot of people have other eyepieces. If you want to use a different eyepiece in Galileoscope, go for it. Try
How well
experiment.
does it like stick in here so that it doesn't fall out? 'Cause
As long as it's just a standard eyepiece, like Plossels are fine. If you have like a big Negler or something that's very heavy, it's just friction, so it might fall out. I wouldn't use anything too expensive or heavy, but
right.
standard Plossels and Kellners and that sort of thing, I've used lots of them and they've never had a problem with them falling
And that's
out.
part of what these little U's are for, right? That's to kind
Yeah.
of slope
Hmm.
inside a bit so it grips better.
Yeah.
Cool. Uh, Guido says, Galileoscopes with CosmoQuest branding, just saying. I probably have stickers I could stick all over mine. And there's another
Well,
link from Tom. Hmm?
we do the Math Moves You event. Raytheon has their own stickers they make the students put on the Galileoscopes.
Of course, of course.
So they do their branding, so it's done.
Sure. I think mine is covered in little colorful stars. Mine at home is covered in little colorful star stickers to distinguish it from everybody else's at the star party. Because I'm a dork. Tom Nathy has a link to 10-Minute Astronomy has some expensive Galileoscope modifications.
Wow, sounds interesting.
Curious what this is.
Yeah.
I'm gonna open that up. Um, let's see. I can screen share that. Ultimate Galileoscope Quest. This is a multi-part post.
Oh my God.
Look at that!
Yeah.
That's amazing. 2-inch yes, that is a 2-inch focuser on David's Galileoscope. Why do you ask?
Yeah.
Oh my gosh. So that's a multi-part post that you can dig into if you really want to trick out your Galileoscope with a guy, it looks like Finder Scope, and what is that? Can you see what that is, what I'm pointing
Yeah,
at?
that's probably something he just put in there to make sure it came to focus with his eyepiece. So it's probably just an extender of some type, but I can't tell for sure.
Funny. Awesome, awesome. So
Because
I will.
some that's the problem with using a diagonal with it is you need to getting it to come to focus with the diagonal can be
Yeah.
problematic. But it looks like that's probably part of his solution to that problem.
Okay.
Now,
Well, I will
one thing that
share
they
a link.
used to have, I don't know if they still do, but I think people found them at Walmart several years ago in the gun department of all places. They found these little for BB guns, these little red
Yeah.
dot sights you put on the top of BB gun, and some people started mounting those on Galileoscopes for finder scopes.
Oh, okay. Well, they make them for telescopes as well. I don't know if
Yeah.
they sell them separately from the telescope
But
though.
these were like little ones. They're about $10. They're cheaper than the ones for telescopes. They just came
Okay.
with like little like stickers on the bottom, so you
Yeah.
sort of peel them off and it's stick it on there. So they're very cheap ones designed for like BB guns, so very very cheap things. But yeah, you can buy of course the good Orion or Orion what makes the red dot finders for about $50 or so.
Okay.
We could go really nuts and put a Telrad on there.
Go to town. Just use
A
the.
little overkill, but hey.
This is your canvas, people. You can get really creative. Oh, that's fun. So I will definitely put all these links in the show notes. So if you're listening to the podcast, we'll put all these links in the show notes. I will include them in the description of the events as well. So those of you watching live or those of you watching on YouTube later, they'll show up in the description. So you can check out all these fantastic links. And thank you, Tom, for sharing all of these
Yeah,
awesome
thanks to our
resources.
Google master there.
Yeah. Oh, you need stuff. Boom. Resources. Awesome. Okay, so we are kind of closing in on an hour, so I want to do some quick announcements, and then we can maybe do some last burst of resources or places people can find stuff. Let's see, the weekly space hangout is this Friday, and I think if I read the description correct, they're going on summer hiatus after this. This is the last one until after DragonCon. So they'll be taking July and August off for the weekly space hangout. Sorry. We'll have to figure out something to do in the interim. So check out the last weekly space hangout of the summer this Friday at noon Pacific on probably from Fraser Cain's Google Plus page, and it'll be on Universe Today. It'll be on CosmoQuest. The virtual star party is also moving to its monthly format. I still need Tom, I know you're a virtual star party astronomer. If you have the date, I don't know when the next date is going to be, but they're moving VSP to a monthly format in part because of all the weather problems they've been having with all their astronomers, weather and scheduling. So they will have a show every month, come clouds or rain or storms or whatnot, because they'll be building up pictures over the month, but then they'll do live observing if it's available. And then I think depending on travel, I know they've been posting some Astronomy Cast episodes as well, so go to the Astronomy Cast Google Plus page to see the upcoming schedule of that. That's usually Monday at noon Pacific as well. And that brings us back around to Learning Space next Wednesday. We have Libby Norcross from the Challenger Center. I'm really excited.
Oh, my good friend Libby.
Yeah, I don't think I've met her in person, but I follow her on all the medias, and so I'm really excited to talk to her.
Yeah, I met her at the Mars Curiosity launch tweet up several years ago.
Cool.
And she actually became one of our Galileo Educator Network fellows last year. So I've worked with her in multiple capacities over the years.
Excellent, cool. So she'll be on next Wednesday. So that is our schedule roundup. Maybe, Rob, do you have maybe some suggested resources for people or places they can find your work?
Well, there's Galileoscope.org, of course, which has the Galileoscope stuff. There's also teachingwithtelescopes.org, which is our other website, which we have Galileoscope information on. So those would be the first two places I'd recommend off the top of my head.
Okay, sounds
good. And of course, I mentioned some other ones throughout here, like the Cloudy Night stuff, which has been posted as well. So those are always fun.
Cloudy Night, I'll definitely add that. Cloudy Nights, go to the Cloudy Night forum.
Yep.
Oh, I just got a 404. Never mind.
I can't remember it might be, is it cloudynights.com or net?
Cloudynights.com. Yeah, I think I went to the old one first. So cloudynights.com will take you to that forum as well. So yeah. Awesome. I will be sharing, like I said, I'll be sharing all these links. I love the font you guys have on the Teaching with Telescopes.
Yeah, it is a nice font. I like that too. We have good graphic designers here.
It's a little Twilight Zone-y. I love it. That's me. All right. Thank you so much, Rob. Thank you, everybody, for watching, participating, listening, and we'll see you next week on Learning Space.
Okay. Thanks, Nicole.
Bye.
Bye.
If I unmute. Hello.
Hello.
Hi, everybody. Welcome to this week's Learning Space. I am your host, Nicole Gugliucci. I'm a postdoc with the CosmoQuest project. My co-host, Georgia, is doing a 2-week-long teacher professional development workshop, so she won't be joining us this week, unfortunately. So yay, Georgia, have fun. I am joined by Robert Sparks today. Hello.
Hello. How you doing, Nicole?
Good. How are you?
Good.
And we are going to talk a bit about Galileoscope and optics activities you could do with the Galileoscope. And I have trusty Galileoscope, not mine, one of the Resource Center ones. Mine is with a pile of telescopes at home. Astronomy Observatory, and I will share a link in the comments as well on the event pages. Yes, I know there are 2 event pages. It's very confusing. Welcome to my life. There we go. So can you tell me a little bit about the development of this optics guide?
Yeah, well, to start the optics guide, we should actually take a step back before the Galileoscope even existed, because it was based on previous work, obviously. When I first came to NOAO in 2005, the big grant we were working on at the time was hands-on optics, and I was hired specifically to work a lot on that grant. And that was a 4-year grant from the National Science Foundation to develop optics education materials for middle school, basically. We worked with the MESA programs, and that stands for Math, Engineering, and Science Achievement, in several states, which included Arizona. I think that's 8 states: Arizona, California, Oregon, Washington, New Mexico, Utah, and Maryland. I don't know how Maryland got in there. They're sort of the oddball geographically, but Maryland was one of the 8 states, and so we developed that, and we'd work with the MESA programs and do teacher workshops each year in those states on these modules we developed. And of course, one of them was called Magnificent Magnifications, which was our 3rd module, which dealt with lenses and telescope optics. And we used those old Project Star telescopes. I don't know if you remember those things or not.
I don't think so.
You're a young one. You might not remember Project Star telescopes. They're these cardboard telescopes that had a red cap on the end. They'd have like a plastic objective, then a little single plastic eyepiece. They gave about.
For all of you guys watching, I see a bunch of hellos in the Q&A. So hi, Douglas. Michael, you win first comment. Hi, Nancy, and good evening over Jeremy Taquito. If you're watching this anywhere on Google Plus or YouTube or somewhere where it's embedded, you can click to where it says join the conversation, and that will take you to the Q&A app, and so we'll be watching the comments there. Hello, Brandon, as well. So yay, thanks for coming, everybody. So yeah, feel free to send in any comments or questions throughout the show, and we will try and get to them through the Q&A app. So, Robert, how are you?
Good.
How is life in Arizona?
Hot and clear. No, not a cloud in the sky for the last week, which has been fun.
Wow.
But the monsoons will start hopefully soon to cool us down a little bit.
Right. And the telescopes pretty much do a lot of maintenance during monsoon season, right?
That is correct.
Monsoon season, for those of you who are actually in Asia and get...
Yeah, it's not quite the same. Technically, it's not a monsoon in terms of the same weather patterns, but it's commonly called the monsoon here. Yeah, July 15th, I believe, is the date they shut down for maintenance till about September 1st.
Oh, wow. Okay.
Still a couple weeks for that, but usually the monsoons, the rains will start a week or so before shutdown, so it gets dicey toward the end there.
Yeah, it just rains constantly, which is nice. I mean, you need it.
Oh, definitely, yeah.
Cool. So I wanted to talk some about the Galileoscope Optics Activity Guide, and I can put a link to that in the, I think, I mean, I've probably have it saved somewhere in my browser, but I just Googled Galileoscope Optics Guide, and it comes up from the National Optical Astronomy